Welcome to Managerial Economics for non-economists. So we want to learn how to differentiate, and this is a prerequisite for everyone who wants to learn economics. So basically, I'm going to teach you what is called the power rule. Differentiation is simply based on this power rule, which simply assumes the y over the x is equal to n a x power n minus 1. So this is all we need to understand differentiation. So if you're going to have y is equal to 5, x to the power 4, you're multiplying. This is called dy with x to start with, because there's y this side and there's x this side. We're going to multiply 5 times 4. Then we're going to subtract 1 from the power 4 minus 1. So the final answer is what we call the derivative. So this is 20 x to the power 3. That is how we differentiate. If you're going to have u is equal to 7x3, this is called du over the x. U stands for utility. So in differentiate, it's called marginal utility. So we're going to multiply 7 by 3, which is 21. We subtract 1 from the power, we're going to get a 2. So this is how we differentiate. So let's try again. We're given a multi-variable, 4x6, 3x5 plus 4x2 minus 10x plus 5. So this is still dy over the x. Differentiating this 4x to the power 6, we're going to get what? 24. We subtract 1 from the power here, we're going to get a 5. 3x5, we're going to differentiate this. We're going to get 15x4. We differentiate 4x2, we're going to get 8x to the power 1, we never write 1. Then we have 10x as an invisible one there. So 1 times 10 is 10. Subtract 1 from the x1 to be 10. The derivative of 5, which is a constant, is 0. So this is how we differentiate that function. Let's try another one. Total revenue is TR is 170 minus 5q squared. Who wants to try to differentiate this?
I can try.
Okay, try.
Hello?
Yes.
Yes, that's dr over, yes, that would be, is it dr over dq?
The TR over the Q. So this is TR.
Yeah. Oh, okay, yeah, so it's going to be 170 minus 10q.
Yes. That is how you differentiate that. Okay. So what if we had total cost, which is equal to 10 plus 5q? I'll differentiate this.
It will be the TC over the Q, which is going to equal to 5.
So the TC over the Q. The total cost when differentiated, it becomes marginal cost. What happens the 10? The 10 drops out as a constant. 5q becomes what? 5, correct. All right. So sometimes you may have implicit differentiation where you're given two variables, X and Y. So if we're going to differentiate this, you start with one letter at a time. The U over the X is called the marginal utility of X. So our dummy is what? Y to the power 10. Then we're going to differentiate 3x5, which will give us what? 15x to the 4. Then we differentiate again the U over the Y. This is called the marginal utility of Y. Our dummy in this case is what? X5. We're going to differentiate 3y10. So 3y10, when differentiate it, it will be what? 30y9. So I'm multiplying 3 times 10, which is 30, subtract 1 from the 9. Of course, this order is deliberate. Okay. This order is deliberate. So you need to start with the letter which comes first in the alphabet. All right, so if that is clear, we can now proceed. Suppose we have a derivative. TR is equal to 4x3 minus 3x squared y7 plus 10 y6. So we're differentiating the TR over the Q. No, the TR over the what? The X. Because we have two letters here, X and Y. So we're going to differentiate only where X is concerned. So what is 4x3, Ronnie? It is 12x what?
Squared.
Then here there are two letters. So we're differentiating what? Like we did here. Remember, when you have U, 3x5, y10. In the first instance, we just cut the y10 and left 3x5. When differentiate 3x5, it becomes 15x4. In the second part, we copied and cut this x5 here, meaning we're going to remain with y10. We multiplied 3 times 10 to get 30 and subtracted 1 from the power to get 9. Now the same application is what we're going to use here. Where there's x, you differentiate. Where there's no x, you consider it as a constant. So 4x3 is 12x2. Then here, we're interested in the x, our y is a dummy, y7. So 3x2 becomes 6x1. Then we go here, plus 10x6 becomes 60, y5. So this is how we differentiate with respect to what? To x. With respect to y, we differentiate as follows. Here there was no x. So this was a constant. You cannot do anything, it remains 0. So here we're differentiating with respect to y. So where there's no x, we consider it as a constant. So here there's no x, 0. Then here we're differentiating with respect to y. So our x2 remains the same. We're going to remain with minus 3, y7. So this is minus 21, y6. Then we differentiate this last part, which is 60, y6. Now, in differentiation, you must understand that it has the following applications. So when you're differentiating, TR comes the TR over what? The Q. So the TR becomes the marginal revenue. TC, we're differentiating the TC over what? The Q. So the T just becomes an M. So this one becomes marginal cost. For profit, we're differentiating the profit over the Q. When you differentiate, it's called the marginal profit. So that's how the song rhymes. If you are differentiating output, Q, there's labor and capital involved. So the Q over the labor, we call this the marginal product of what? Labor. So since we have Q and labor, we can differentiate it again, the Q over the capital. This is the marginal product of what? Capital. Okay. Utility as well is with respect to X and Y. So du over the X, this is called the marginal utility of what? Of X. Again, with respect to X and Y, you can differentiate du over dy. This is called the marginal utility of Y. So this is how the song moves with differentiation. And you must understand that anything we differentiate and equate to 0 is a maximum or an optimal point. So I need you to understand this very clearly. In optimization, you cannot do without understanding the concept of differentiation. Okay. So we can try now to apply. So let's go to the formulas, because differentiation will also go hand in hand with the formulas. So if you have total revenue is equal to price times quantity. The marginal revenue is called the TR over the Q. When we equate the marginal revenue to 0, we are maximizing revenue. Total cost is a function which is given by total fixed cost plus total variable cost. When you differentiate the TC over the Q, what we're getting is what? Marginal cost. So when marginal cost is equal to 0, what are we doing? We're minimizing cost. We can't maximize costs. When MR is equal to 0, we are maximizing what? Revenue or sales. So far, together? Any questions so far? Is it clear? Is there anyone behind at the moment? Please ask. Are we together so far? Okay. So with these formulas, we'll be given the price function, for instance, as 170 and as 5Q. The total revenue is simply price times quantity. This is a revenue analysis. So 170 minus 5Q, we put a Q outside there. So our total revenue becomes what? 170Q minus 5Q squared. So to differentiate this to be the TR over the Q. So here we're going to have 170 minus 10Q. So this is how we differentiate. This is called our marginal what? Our marginal revenue. When our marginal revenue is equated to 0, we are maximizing revenue. So 170 minus 10Q equated to 0, we can solve for Q. Q stands for the output. When you divide both sides by 10, our Q therefore becomes what? 17. And we can identify the price by substituting back in the original price function. where there is Q, we put the 17. So we get our 85 as the price that maximizes revenue. Okay. So that is how we move. Let's try to differentiate this. Suppose we have the following. Ronnie, I want you to try this. Suppose we're given price is equal to 1,000 minus 2Q. Let's maximize revenue. How do you maximize revenue? Step 1, find the function that you want. Which function do you want to maximize? Total revenue. Step 2, differentiate that function. What function are we differentiating? The total revenue, which becomes what? Marginal revenue. Step 3, we equate to 0. Step 4, we solve for P, solve for Q first. And P. So let's go. Step 1, Ronnie, how do you find the total revenue?
So total revenue is equal to, that's P times Q. Yeah, so that will be 1,000 minus 2Q multiplied by Q.
Correct.
So that will be 1,000 Q minus 2Q squared.
Correct. Step 2.
So we're going to differentiate. That will be the TR over dQ. So that will be 1,000 minus 4Q.
Then?
And then we're going to equate to 0. That will be, yes. So negative 4Q will move to the other side and it will become a positive 4Q, and then we divide both sides by 4.
Correct. So what becomes our Q? 250. And how do we find the price? Substitute it back into the original price function. Okay.
Yes.
So this is how we get our revenue maximized. This is how we get our revenue maximized. Okay. So anyone who would want to try, we do another maximization. So by the way, maximization is a key topic in this course. So sometimes we'll be given two functions. We're given price is equal to 85 minus 2.5Q, and quantity, and maybe total cost will be given by 20 plus 25Q plus 2.5Q squared. So they're asking you to do what? Maximize revenue and maximize what? Profit. The two things. Maximize revenue and profit. 10 marks, 5 for each. So how do you maximize revenue? Maggie, take us through the steps. Maggie and Brian. How do you maximize revenue and profit? Let's start with revenue. Step one, find that particular function, which is the total revenue. How do you find total revenue? Ronnie?
Price times quantity.
Price times quantity. So what is our price?
It's 85.
At 5 minus 2.5Q. So what do we get? Okay, who wants to take it up? That's our total revenue. What's the second step? Ronnie, what's the second step?
We need to differentiate.
Differentiate. So the TR over the Q. This will be called our marginal revenue. What do we get when we differentiate?
85. So that would be 2.5 times 2Q. That's a 5Q, yes.
Then step 3.
We have to equate to 0.
5 minus 5Q. Then step 4.
To find Q.
Okay. So how do you find Q? By making its subject.
You divide both sides by 5.
By 5, correct. So here we have 85 over 5. So what do we get here? 17. Then how do we find our P? How do we find our P?
We will substitute. We will take the given formula and then we substitute the 17.
We take it into original formula, okay? Seems there are 2 people in one area and there's some feedback. All right. So that is what we do. Okay. So when you take it back into that original formula, the price, we're going to have what? 85 minus 2.5. So here we put 17. We're going to get our price as what? 42.5. Okay. So that is how we go about it. So let's go to something else. And for some of the questions, it gets them from your modules. So let's go now to the total cost. Well, given the total cost as what? 20 plus 25Q plus 2.5Q squared. So from this function, which one is our total fixed cost?
20.
The constant, which is 20. And which one is our total variable cost? One with the letters 25Q plus what? 2.5Q squared. All these are variable costs. So how do you find the average fixed cost? Who remembers? Anything average is anything divided by quantity. The total fixed cost over quantity is called average fixed cost. So what becomes the average variable cost? It's the total variable cost over what? Quantity. So our total fixed cost here was 20 over Q. You can't simplify any further. Our variable cost is 25 Q plus 2.5 Q squared. We divide by Q on both sides. So here we're going to have what? 25 plus 2.5 Q. That is our average variable cost. Total variable cost, we can add our average variable cost and our average fixed cost when you add them together. Average variable cost and our average fixed cost. So here we have what? 20 over Q plus 25 plus 2.5 Q. Let's add the two variable costs, or alternatively, the total cost we divide by quantity. We get the average total cost. This is the average total cost. Okay. Let's go to your module just to validate what we've been discussing here. So under revenue analysis, we talked about the price being total revenue being price times quantity, average revenue being total revenue over quantity, margin revenue and differentiate. Total cost is total variable cost plus total fixed cost. Then average total cost is total cost over quantity. Marginal cost is the differentiated total cost over quantity. So if we have a function like 2R is equal to 75Q minus 4Q, the marginal revenue, differentiate 75Q, it would be 75. 4Q squared would be 8Q. The total cost, it is 1Q2 plus 7Q plus 23. Marginal cost will become 2Q plus 7Q. What happens to 23? It drops because it's a constant. All right. So firms usually maximize their profits or maximize their output, but minimize costs. We can't maximize what? Costs. And the profit is the difference between the total revenue and as a total cost. So when we want to maximize the level of output, it is maximized when marginal revenue is equal to marginal cost. So these are the principles you need to understand. So when we have a function of the total revenue and total cost, as long as between A, the total revenue is above the total cost, we call that the profit. Where the total cost exceeds the total revenue, we call that a loss. Okay, so this stretch between A is called the profit because you can see the total revenue is on top. But where the cost is on top here, this is where we're making our losses. So if this is 2, 3, 4, would advise the firm not to produce below 2 units and not to produce above 4 units, otherwise they'll land themselves in a loss. All right, so let's look at this example. I repeat, there are 2 questions or 3 questions that will always come from your tutorial sheets to see whether you've been studying them. Now, I want somebody to lead us through. We have been given the following function. Price is equal to 30 minus 2Q. Let's find the total revenue and maximize this. Who wants to try? How do we maximize this function? Total revenue is equal to what? Maggie, price times quantity. Herin, Misozi. So our price is 30 minus 2Q. Then you impute the Q here. So our total revenue will be 30Q minus what? 2Q squared. So this is called our total revenue. Our marginal revenue is when you differentiate this, the TR over the Q. So 30Q becomes that 2Q squared becomes what? 4Q. So this is called our marginal revenue. So to maximize it, we equate to 0. So here we're going to have what? 30 minus 4Q. Then when the 4 comes inside, we equate to 30. And divide by 4 on both sides, and by 4 on both sides. Our Q therefore becomes what? 7.5. So this is our Q. So to find the price, we substitute this in the original price function. And whenever we're maximizing revenue, the price is usually half of the intercept. If here there's a 30, the price will be what? A 15. Here there's 40, the price will be 20. So this is 30 minus 15, which is 15. So this is how we maximize. This is how we maximize this function. Let's just verify. So marginal revenue was 30 minus 4Q. So the exercise I want you to do is this one. You can capture it.